Hey guys, Frank Victorine here. I'm going to go ahead and switch over to the camera screen here. So what I have today, this little guy, it's a injector cleaner, injector volume tester, and DC ignition coil. Um, I decided to make it self-powered, so you can take a 9-volt battery. I would highly recommend a rechargeable battery because ignition coils can pull up to 6 amps. I assure you that little 9-volt battery is not going to last very long. Might be good to have something that's rechargeable. Something else I'm going to mention before I forget it, that this terminal, this microcontroller that I built into this thing, it will handle all the way up to 18 volts. And the MOSFET's good to 55 amps. I don't know that it would actually take 55 amps, but that's the rating on the MOSFET. I'm not going there. It might do it for 20 seconds, but anyhow, it'll definitely handle an ignition coil. Um, that you can add more power to this thing, and what it'll allow you to do is to get the injector to cycle a lot faster. With 9 volts, it'll definitely cycle it at lower frequencies, but I don't think you can hit that 20, 30, 100,000 hertz with 9 volts. You just don't have enough magnetic strength with enough voltage to get the thing to oscillate that fast. So let's just talk about connections here. Um, if you plug it in, and I'm gonna have a second video that actually has it hooked up to a water source that shows how just a demonstration of how these things. You've got the three buttons. You got an acrylic clear cover with them clearly labeled. You can see the microcontroller down inside of it. Um, Oh, something else that I'll mention again, that I have two covers. I built one with a black cover, and the black cover is actually quite a bit nicer. The problem with clear acrylic is that these are laser cut, and what happens is the laser comes down with something clear. It bounces all around. So it basically reflects off of everything, and you get a cut that's not as clean anytime you're dealing with something clear. So these things, and I'll get you a clear cut. I mean, these things are money. The clear ones are pretty good, but they're not as good. Um, I don't know. Tell me which one you want, and I'll send you the whatever cover you want. So let's talk about wiring just for a second, right? So this thing, these are obviously all of them are mysterious wires. So it's really pretty simple. The larger gauge wires, these two here, those fit onto the primary side of an ignition coil. These are the typical connectors that most DC ignition coils will have on them. Then the smaller ones you'll also see, and you'll see that they're color coded. You've got power, which is in this case, it's 9 volts, and then you have ground, which the microcontroller pulses the ground to activate the coil, to oscillate the coil. Then you'll have power and ground for your injector. Neither of these are directional, as long as you've got a red connector and a black connector, and it's the right size of connector, it'll work. Okay, guys, red to red, that doesn't work. Black to black, that doesn't work. You have to have power, you have to have ground. Um, okay, enough out of me on that. Let's talk about some of the other design stuff here real quick. And it's going to disconnect that little guy, and we're going to swap over here. Oh, so here's the little cover that I modeled. Everything that I make is in Blender. I don't think that there's a lot to show here. I actually redesigned this cover. I'm on the third iteration right now. Anyone that's done any sort of design stuff themselves, things are never absolutely perfect, and there's always ways to improve it. And I could probably go through another 3 or 4 iterations till I was really happy with it. But the battery doesn't fall out of it. The case feels like it's rigid enough. You could get to the USB port on the backside of the microcontroller if I ever wanted to improve the software. Um, the connector fits through the wire size. I mean, there's just typical design stuff. Um, Anyhow, so let's minimize that. I always just kind of disclose everything that I make. Here is the PCB, the printed circuit board. This is actually what I sent off to have designed. I'm going to flip back so I can show this to you here real quick. there's the actual, right? So there's one of the little microcontrollers. Pretty cool. I mean, it works. It's I've tested it. Uh, should be good, man. Here's the schematic, and here is the model version that shows, you've got your three buttons, you've got a couple pull down resistors, there's a diode in it, there's a couple other little circuits, but pretty simple, really. Um, Most of the effort actually went into the programming. Um, I think I can probably even show you the programming, maybe. Yeah, heck, there is just a quick overview of some of and I always build everything into tabs so I can keep all the different functions straight. Anyone that's programmed microcontrollers, these are all programmed in C++. Wouldn't claim to be the greatest programmer, but it's my junk. So anyhow, oh, what should I say with all that? China, do not steal my design. Thank you. So here's the project today that I'd like to share. This is a multi-function tool. It has three different functions built into it. It's an injector volume tester, injector cleaner, and ignition coil tester. Just a couple other things about the design. It was designed to be fully modular. In other words, I can take any one of these components, I can disconnect it. There's the microcontroller. The MOSFETs can be disconnected. The sub harness is removable. You could even replace that LED. You could plug it right in, it'll work. There's the backside of that little guy. So next coming up, let's see this thing in action. Hey guys, so if you select the middle button, this is the volume tester. And the way that this thing works is you run a regulated 50 PSI to the front of the injector. You plug in the connector, you press the button, and there's a timer built in that actuates or activates the injector for exactly 60 seconds. And of course, depending on the number of holes the injector has, the size of the holes determines the flow rate of the injector. Most of the manufacturers of the injector, like Nippon Denso, actually have a sheet that tell you the recommended PSI and also give you a flow rate, so you can look up you can perform this test and find out if the injector is actually flowing at specification, which is extremely useful. I also built in a small delay of approximately 1 millisecond that opens and closes the injector. And the reason that I did that is that if the pencil wasn't moving or there was a problem with the coil winding or something, or even input voltage to the injector, that all of those types of problems would show up with the injector volume test. And at 1 millisecond, it has almost zero impact on the flow rate of the injector, because we're talking about, it would flow 99.995% of the recommended flow rate. Anyhow. And you press the first button and it cycles at 100 milliseconds, then it moves into the ultrasound frequency and moves all the way from 1 kHz to 100,000 kilohertz. And that you'll find that there's no injector on the planet that I'm aware of that'll run at 100,000 hertz. You'll notice when I get towards the top, the injector starts to get really loud, and then it just sort of just stops. It's just not spraying fuel anymore. So again, ideally here is that you take whatever the injector is and that you tune it for the highest frequency. Last is the ignition coil tester. Caution, this little guy will get you.